We tried this the other day, and it did not work. We're going to try again. So right now, you guys, I don't know what the problem was. I think it was the bubbles, weirdly. But anyway, so you guys have a data table that looks something like this, yes?
Yes.
Okay, except you obviously you have these numbers filled in, right? So the idea is your coefficient of friction is a predetermined thing, determined by the two surfaces that are in contact, right? In this case, the rubber soles of the shoes and the blue lab table, yes? Now, how much force friction exerts is a function of the normal force, right? And as you went through and changed the weight of the shoe, you changed the normal force, and that changed your force of friction, right? Okay? So, what I would like to do is see if we can come up with a graph that shows us what the kinetic friction force is as a function of normal force. Cool? So, let's try this again. Hopefully it'll work. Here we go. So you want to highlight the two columns that you want to make your function. Usually I find that it works best if you highlight what you want to be the x-axis first. Okay, I think I said all this the other day, but I'm saying it again. There we go. So then hold down the control button, and that will allow you to select other regions.
Is it recording?
It is recording, yes. Thank you for reminding me. All right, everybody got that?
Yes.
All right, then you click the little chart thing. So I'll tell you a thing. So this, what you're looking at right now, that's a chart. All right? Dear Google, what we're inserting is not a chart, it's a graph. All right? I don't know why they call this a chart. It makes me really angry. Here we go. I'm going to insert what they call a chart, what I would call a graph. What kind of graph do we want to insert? Not a column chart, but a scatter plot. Hooray! There we go. All right? Good?
Yes.
All right. So here are the other things we need to do. Thing one, click on Customize, and there's a bunch of stuff you can tweak, all right? First and foremost, notice that our x-axis only goes down to 2, right? Really, because of the information we're trying to gather from this, I would like to be able to see the origin, 0, 0, all right? So I'm going to click on horizontal axis, and right here, see where it says minimum value? I'm going to type the number 0. Okay? All right, now, there are other customizations you can make, like
Text color.
you can change the text color. The thing that I tend to find helps me the most is I like to change the grid lines. So there are major and minor grid lines. The major grid lines will get a number. The minor grid lines will not, all right? So I would like to be able to see where 1, 2, 3, and 4 are, all right? So here's what I'm going to do. I'm going to leave major grid line the way it is, but minor grid line, I want to insert 4 of them between each major grid line. Does that make sense? Like I want to insert 1, 2, 3, and 4. So major grid line count, I'm going to click 4. Nope, that was horizontal. Wrong axis. Darn it. I did the same thing the other day. All right, sorry. So for vertical axis, let's do 3 so that we get a half, 1, and 1 1/2. So we're going to do 3 there. Cool. And then on
If you go to grid lines, then you have to change.
grid lines. Oh, right. Yeah, thank you. Okay, yeah. Apply to, thank you. Vertical axis. Yeah, thank you. Horizontal axis. And we want 4. Very good. All right. And the other thing you can do if you want is you can change like the weight of them. I usually make the major grid lines a little heavier.
And make them pink.
And obviously, if you have preferences, you know, if you want to make them, you know, different colors or whatever, you can do that.
Make them yellow.
All right. So whatever. Got it? All right. Other stuff we need to do. Chart axis and titles. You need to put a title on your graph, right? I'm sure Mr. Tyson is very particular about this, right? So what do we got? We got, let's see, kinetic friction. Oops. As a function. Why can't I type today? ION of normal force. Cool, it puts it up there. We want to label the axes. So horizontal axis, normal force. What do I need to do?
Newtons.
Newtons. Vertical axis. Kinetic friction. Oh my glob. ION. Newtons. There we go. Cool. All right. I don't know that we need a key on this, right? Because there's not that much data, right? It's telling us this is kinetic friction, this is normal force. Oh, shoot, no, we do need this. And I'll show you why. All right, so the most important thing we want to do now is we want to
Change the font.
Yes, absolutely. No, so the most important thing we want to do is get a linear regression for this. We want to figure out what's the equation for this line. All right, so Google Sheets is not quite as sort of robust as Microsoft products, but Microsoft costs money, Google doesn't, so here you go. All right, so what you want to do is go to Series. This is the thing you may not have done before. Go to Series, click Trend Line, all right, and it'll ask you what kind of trend line you want. And it looks to me like the data is suggesting that it's linear, right? So I'm going to leave it on linear. But if you ever wanted to, you could do exponential, polynomial, logarithmic. The one thing it doesn't do that makes me really mad is inverse. Like you can't do a 1 over x function.
That's big L.
Big L, yeah. All right, so great. Now I've got this line. What's the equation for it? Well, down here, if you go to label, you can either type in a label for that line or use equation. All right, so can you guys see this or no? Can you read it? So right now it says,
I like Roboto.
all right, you're welcome to mess with the font if you want. It's cool.
If I do it in Comic Sans, can I get extra credit?
Yes. All right, so here's what this says. Please listen. Y equals 0.405x minus 0.0149, right? But for us, the x and y have meaning, right? What is the y value?
The kinetic.
Kinetic friction. So we've got force of kinetic friction equals 0.405 times what's our x value? Fn minus our stupid y-intercept. But what do you notice about that y-intercept? Pretty close to 0, okay? Now some programs will allow you to force your y-intercept to be 0. I believe the Microsoft products will let you do that. Here, we're just going to kind of keep our fingers crossed and hope that we get as close to 0 as we can. If not, unfortunately, this program doesn't let you do anything about that. Okay? But so if we assume that this is 0, then what's the significance of that?
Coefficient.
That should be our coefficient of friction, right?
Ooh, that's fun.
Does that make sense? Right? This is a thing that shows up as an FRQ on an AP test probably every other year, where you have to draw a graph, you draw in your straight line fit, you find the slope of it, and that slope means a thing. All right? We will practice that more throughout the year, doing it by hand. But here's how you can do it using fancy spreadsheets and stuff. Okay? Go ahead. I don't remember off the top of my head. We'll look into all that before, but I don't like to play the guess what's going to be on the test case. Like, you guys will know enough that you'll know how to do everything anyway. All right.
You only need like a 70.
Not even, like a 60 or something. It's ridiculous. You guys are going to all get 5s. It's going to be amazing. All right. Does this make sense?
Yes,
That's a lot of big.
All right.
I've got like 60s before. There wasn't an AP test.
Okay. So I guess the other thing you could do if you really wanted to is now that I know what these numbers are, I can do this and I can do custom. And then I could type in custom label FFK equals 0.405 FN minus 0.0149. And then you've got the right variables and everybody's happy.
Do you want us to keep the...
That looks nicer to me, I think, right? Instead of the arbitrary x and y. Oh, why did it add these points in? I don't like that at all. Did I?
Yeah, data level go up.
Oh, I see. Got it.
It's definitely the 5.
All right, so does that make sense? All right, so here's what I would like you to do sometime in the next 3 days, let's say.
Whoa.
And you've got you've got tomorrow to work, and if you need more time, we'll figure it out. All right? So, thing 1. Find your coefficient of kinetic friction, just like I just showed you to do. Good? Thing 2. here's what your setup is going to look like. Shoe, pulley, theoretically frictionless cart with mass. Okay? So you know this mass, right? Don't you know the mass of your shoe?
Yes.
I do.
So, let's do. John, wait, what's going on over there? So let's do this. I don't. Part of the problem that I had with my honors class is that everything was moving so fast that there wasn't enough data to collect. So let's do this. We're going to do shoe plus 500 grams. Okay?
What are you doing right now?
What are you doing, man?
Is this the lab? Or is this
Yes, you guys are going to make a prediction. All right? So you guys are going to add 500 grams to your shoe. Clear? All right? You will have time before we do the actual lab to find this angle and the mass of your cart. Okay? So thing one, I would like you to predict if you're giving your theta the smallest mass m for the cart that moves the shoe.
Are you still recording?
Yes. Right? Does that make sense?
Wait.
So basically what I want you to do is I want you to write an equation that is will find the smallest force that'll make the shoe move as a function of theta. Okay? Yes.
When we're measuring out theta, since the ramp isn't like a paper thin line, do you do it from like the bottom of it or the top?
Yeah, so the bottom of the ramp will make an angle with, so like if you zoom in, sorry, my board needs to be calibrated. So that's the ramp, here's the floor, right? So yeah, you want to find this angle there. Does that make sense? And then the top would be parallel to that. So that's valid.
Oh, yeah, yeah.
Okay. Lucy, you had a question, and then Sean?
So if you're, what about static friction? Want to take more?
Yes, yeah. So we're going to end up going above and beyond that. Do you know what I mean? So, yeah, so I guess here, how about this? At constant velocity. How's that? Good? All right, everybody good? Yes?
Are we going to be, is this hypothetical or are we going to be given theta?
Well, eventually you'll be given theta, and I'll say, all right, now you've measured theta, plug it into your equation.
Okay.
Do you know what I mean?
Yeah.
Good? Everybody follow or no? Anybody confused?
Wait, is this?
Yes.
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 That was like a test question.
Yeah, no. This is for the lab. You guys started this lab last week, and I wrote up a procedure for a part 2 of it, but I'm tweaking it now, and this is the tweak. Clear? All right. Everybody good? All right. Once we find this mass, there's going to be a part 2 later on where I'm going to say, all right, now let's make that mass bigger, and you're going to predict the acceleration and the tension.
So,
Cool?
tweaking the tweak.
So we're tweaking the tweak. Yes.
We're gonna tweak that tweak?
Nope, I don't think so. I think it's just the 2 tweaks.
Okay.
All right. Did all of this make sense?
Yes.
Okay. Cool. So the making your fancy graph, all of this stuff you ought to be able to do from any computer, either in my room or in the media center, library, sorry, or whatever. Good? Sorry, we called it the media center in my old school, and I still have it reprogrammed to my brain.
That sounds so fancy.
I know, right? Okay, everybody good?
Yes.
Use it more.